so bit fields are also implemented this way. What you do in D is, I want a bit field of 64 bits. First 17 bits will be a uint, and the next one will be a bool, a 1-bit one. So you describe your bit fields with type information in every field that you want. I don't have that as an example. Okay, further, after template mixins, now we have string mixins. This is more like macros. You generate a string at compile time, like generating a macro at compile time, and you inject that string as code. For example, make empty struct returns struct, the name of the struct, and curly braces. This is an empty struct. You can mix in, make empty struct, and you just mix in code. You generate code at compile time and mix it in to be used in your program. Oh, okay. So we use string mixins in operator overloading. Let's say you're defining an int of yours, either by-int, big-int, whatever. The operator overloading functions, operator functions are all the same. The only changing piece is the operator itself. You will always return a plus b, or a minus b, or a divided by b. So what you do here for my int is op binary, and this operator overload takes a string of the operator and it comes in as a string. So you say op binary my int that. So I went a little clever here. I created an array of plus, minus, star, divide by that can find the op. So this function is only available if the op coming in is found in those 4, and then mix in this code. Return my int I, whatever the op was, that I. So I'm generating code and mixing it in, and it works for plus, minus, times, and divide by. I think this is a big win compared to C++'s many operator overloads that we need to write. Yes, a question, please. Everything happens at compile time, yes. So what the compiler does is, when the compiler is compiling this op binary, it realizes they want me to mix in something. It goes in and compiles this expression, runs the expression at compile time, and the expression produces a proper string, puts that string inside op binary, and now it's ready to compile the op binary itself. So you get 4 versions of this op binary if you have 4 different calls to this with the 4 different operators. Question?
So what happens if instead of opposite like function has sometimes type? Yes.
Okay, the question is, what if you supply an op with some side effects at runtime? I don't think this will work because op binary in this case is a special syntax, operator overloading syntax of D, and it takes only one symbol, one character, depending on what exact operator is coming. It might be the modulus operator or the tilde. We have many operators. I just filtered into 4 of those. And I just tested, this much code, this simple code has all the 4 arithmetic operators defined for it. Simple. Okay, here's another one. Now I will write one code with you here. Look at this syntax. Let's say I want a tuple, which I define to be the first tuple member will be an int, and I want to call it foo. The next one will be double, and I want to call it bar. So if I write a tuple that supports this, I should be able to say t.foo equals 42, t.bar equals 2.5. Okay, now I'm going to write this code, show you how this code is done. Here it is. Tuple takes any number of template arguments. Static for each, so I'm going through all those arguments at compile time, taking note of I, the index of it, and every arg. Static if is arg. Now you don't know what this is arg means. Arg is a type. If arg is not type, this fails. So if arg is a type, I want to mix in. Look at this. The type, the string of that type may be int. And then I'm going to put an underscore, the number of that thing, maybe underscore 0, a semicolon. So I'm writing code here while I'm iterating through the template list. Else static if is type of arg is a string. Meaning, did I get a string here? Oh, okay, in that case, I will write a function. Auto ref, the name of the function, like foo, and I'm going to return the previous guy that I created, underscore 0, or whatever that variable was. So I'm using I-1, because in my documentation I said, give me a type and a name, type name. So I know this name belongs to 0, and this name belongs to 0, 1, 2. Else, in any other case, I static assert, and look at this beauty. I can generate a formatted static assert message saying, blah is not a valid tuple template argument. So I write this code, and this code is the equivalent of this struct for this example. The code created int underscore 0, created a full function that returns underscore 0, double underscore 2, returns underscore 2. When you compile your code, it can get very difficult to debug this situation. What is being generated? What are you doing? The compiler has a special flag where you can say, please dump all your instantiations in this file, and in that case, compilation error points to that file's line. So if you use Emacs like I do, you click a key and go to that line and see your mistake.
So there's a pattern there, right? If you give it int, then
Yes, there's a bug in there. Int full will be a bug. Yes. So the proper implementation of this type is left an exercise to Christoph's email. Yes, it doesn't check for errors, but you could check very easily. I think. Maybe not. But that's okay. For example, you can say the argument's modulo 2 is 0, like you want 2 of them. And then you can have a one pass going through, saying type name, and you can check for all of that. We have a catch-all operator on dispatch. This is very interesting and can be very powerful. If you have an object that you are accessing a member of it, which doesn't exist, normally it's a compilation error. This foo doesn't have the M member. But if it has an op dispatch, the compiler will call your op dispatch at compile time, saying, this guy is calling you with this member. So this is a catch-all member grabbing operator. Okay, what you're doing is when you have an op dispatch, the name of the member comes in as a string, and in some cases I have a value which is a type in this case. So well, I'm calling an XML element here. Okay? This XML element has an associated array, which is a dictionary in Python sense or a map in C++. String keyed string attributes and a tag. So every member that doesn't exist will hit this op dispatch and enter the name of that member with the value passed in, converting it to string. And here's the code. I create an element, img, which is an image element, dot source, dot alt, dot height, dot width. I'm assigning to its members which don't exist. But they all go to that op dispatch to build up this attribute dictionary. And when I string it, convert it to string, I use the tags and attributes, and I get this XML element. See, this %s belongs to tag, and there's this extremely funny, unusual syntax. Percent open parentheses, percent close parentheses. This means for every element of this container, repeat this syntax. %s equals double quotes %s. I'm not going to go into more detail, but in the end, this is what you get. This is very useful in some cases. You don't have to write those functions one by one if you want to support source, alt, height, width. And I especially make a point here, the usage is string, int, but because I call to string here, they're all converted to string in my map. And string to string string to string conversion is zero cost. Because we have all the introspection, we can say, oh, to string is called with a string type, sure, return the same thing. No cost. Whew, done. I mean, the first section is done, 2015. So I have 1,000 cuts of D. Shall we start? Or do you want to take that 5 minute break?
You want to take a break, or you want to just keep going?
Okay, keep going. So 1,000 cuts of D is stuff that makes your life easier. C++ does not have equivalents of these. So let's see what I have prepared. Oh, printing objects. So you want to debug something. What's the value of this object? Look, my struct, it has no other functions in it. I can right line any struct. And here's the default implementation of that printer. I don't need to write a whole stream left shift operator to print every time. It's available at any moment. Plus we have this pragma message that you can print compile time expressions at compile time. Challenge to my C++ audience. Can you print the size of the type at compile time in C++? I'm curious, what is the size of this type? Is it 32, 64? Easy knows how to do it. Sorry? Easy is asking, does the compiler still have to compile? That would be nice, but so the quick answer is, it's a tricky business. Yes, you have to create a compilation error where the error contains your size in it somehow. I think, allow me to get on my soapbox. I think this is an embarrassment. And C++ will get this kind of introspection in 2023, hopefully. Louis Dion is pushing for introspections, right? Yeah. I think it's an embarrassment. I'm sorry to say, but we enjoy this kind of stuff just every day. So D wins pragmatically, my friends. And C++ is unhelpful. You don't think... Oh, good news. It is not going to be 2014. I was wrong. 2016, 26. What? These are so large numbers. Question.
So, 30, 40 years ago, we had these things called symbols. And about all symbols for programming types and sizes.
Awesome.
Random reference.
Yeah. So 30, 40 years ago, yes, 30, 40 years ago, you could dump all the symbols which contain the sizes of the types and variables. Yeah. So, Social did not know about that. Okay. Contract programming. We are waiting for contracts in C++. Look at this view. This is so helpful, and I did use it in my project here. You have a repeat function. It takes a string and it takes a count. Oh, here's a precondition. String must not be empty. Count must be greater than or equal to 42, otherwise I will print invalid count. Result, length must equal. So I'm checking my post conditions here. This is basic contract programming. I think IFO language popularized this, designed by contract, I think, DBC. We call it contract programming. And we have invariant blocks for user-defined types. If I have a wall clock, I know that hour and minute must meet certain criteria, and I check my invariants in there. And you can turn all of these checks, which can be expensive, with the release flag. D wins for an eye for correctness. C++ loses ever deferringly. Defer to C++ 23. The question is, when are these checks run? Every time you enter the function and every time you exit the function. If you're asking about the invariant, invariants are checked every time you exit a public member function. Private member functions don't get the checks because during your private members you can be in an invariant invalid state.
Oh, in other words, this is just syntactic sugar for the service.
Yes, this is just syntactic sugar for asserts. The question is, these are just asserts, what's the big win? I think invariant is the only one in this case, because you can move all those checks inside the function as asserts, before and after. And once you turn your all asserts, I'm not sure, maybe you can turn them selectively, like turn off contracts but not inside asserts. So this is just syntactic sugar. Yes, yes.
How can you optimize based on the
Can the compiler optimize based on the contracts? You betcha. Because I say that because one of our backends is the LLVM backend, and I know LLVM is guilty on doing such things.
well,
So yes, these end in the code that the compiler looks at. Yes, they can do that. Yeah.
Are there tools to look at certs and check for code or statically prove or find bugs in code?
Okay, I'm not aware of tools that look at asserts to find bugs in your code. I don't know. I haven't heard any for D. I don't know. What does C++ have that? Other languages?
I was thinking was
yes.
no.
Yeah, raise voices.
Yeah. I don't know. I haven't looked too much at what other languages do. I assume that there are some that do it.
Okay.
But yeah.
Yes, but we know compilers take advantage of assert expressions.
Yeah. What I'm thinking is if it can tell you that
Yeah.
hey, you're setting the power to 24. Now you've got a bug.
Yes, but I'm not aware of correctness. Tools search for correctness from the assert expressions. That's the question. Public memory function. No, the invariants do not check when you directly access hour or minute. But as a proper coder, you might want to change hour and minute to member functions without changing the syntax. I'll get to that. You can convert them into property functions with ease. Another question?
So, people have this idea that you have an overriding function, second class. Why?
Yes, I know. Yes. So we follow Eiffel's idea of making the conditions stricter or looser depending on where you are in the hierarchy. Yes. We have that too, yes. Okay, I've already mentioned this, assertions with messages. So look at this, I have a static assert that will once your T have a record member, and I can write S does not have a bar member. This is very helpful. You see exactly what went wrong. You produce your assert messages. So that was static assert. This is regular assert. Bar value 0 is less than 42. You can print these helpful messages. And I failed to mention, but this bang string from the previous talks, you can guess the string is a template parameter to format, and all of these strings are checked at compile time that they match their parameters, the parameters that the format receives. I used more than 200 format strings in my D code that I used here, and this was a lifesaver. I never used the regular runtime check formats, because the trouble is when you write these expressions, they explode only there's a problem. And you don't check your code for the problem statements, for problems. So you want your formats to be smart and give you the real result every time. Okay. Oh, D wins assertively. And C++ wins limitingly. Because C++ also allows messages, but you're stuck with C-style strings. This is actually a wonder to me. C++ now has context. You can execute functions. Why not say, we made them const experts automatically. You can use any expression that produces a string in your assertions. But because there's an Eiffel standard behind it, somebody needs to propose, and many people need to analyze and get to that. Maybe this is a benefit of D. As soon as you look like something makes sense, it's in there.
So if we're going to
C++ should not withdraw from my soul. I mean, too many heads. I don't want to get into that. I mean, one head. Walter is the benevolent dictator. It has a community leader guy, second guy. And then we have forum-connected community, conference-connected community. That's D.
See, you're selling that as a benefit, but there's also a downside.
Yes, nothing wins. And I have a design by community versus design by community slide. I don't pick anybody there. So there's pros and cons of the two things. I agree. Yes.
Has become successful on a wide scale without using some of those organizations.
Yes.
For example, that is not sufficient, but it is necessary to have entities that higher than those organizations. They will market this for sure.
I'll just summarize. Every language needs standardization to be successful. No language succeeded without some sort of standardization. I hear that.
So, for example, one of the arguments you make is that D is a safer language.
D is a safe language.
Yes. But if I'm a company that's making a car or a plane, do you have a safety certified D compiler that I can?
Yes, the point is very good. If I'm a car or if I'm a company, can I get certified D code? Yes, you can. There are companies that certify compilers, but it's not done. If they require a standardization committee behind it, no, D cannot get it. But if you get people looking at the code and certifying, which I believe is the way it's done in practice, yes, you can.
I think you would be almost impossible to certify without having some sort of specification.
Okay, I agree. So the comment is you would need a specification for the language to be successful, yes. Of course there's a specification which is on a website which may change quickly as features are added. Okay. Source documentation is Cehreli. Okay, we have a question.
One comment on the previous one. Part of the reason why you can't do this very well in C++
Yes.
is you don't actually have compound type strings.
Well, this we can do in C++. We talk about this all the time. Like this being the next step.
23.
But 23, but you need the allocator.
You can do that. You can build this. You could have done this in 20 if somebody had written it. We now have the technology in 20.
I think that's what Richard had
We
said.
have context for strings, so we can have these.
So the comment is the reason why this cannot be done until 2023 is C++ did not have context for strings, but 23 has all the...
20 is.
Okay, 20 has context for strings, but 23 will have the allocation for this kind of stuff.
Everything is there in 20. We just didn't put the feature.
Okay, so 23 will have this feature or equivalent of this. Okay. Source documentation cannot be mentioned.
We have been using this because it's core integrated versus automated GC6.
Yes, where can I use D is the question.
Doesn't want to do kids.
I have, okay. So the question is where can I use D? We have 3 backends for it. One of them is DMD. I will get to that actually, but which requires x86. We have LLVM. You can use any backend that LLVM has. The other one is GCC backend. It can theoretically run on whatever GCC or LLVM supports. But it's not ready for on your mobile phone, for example, mobile platform, because I hear forum posts saying we should get it there, we should make it easy to use. There are ways of doing it with cross-compilation or some techniques, but it's not there. Yes,
It's almost 2020. And an activist person like myself might say, well, if this isn't the language, only language that has appeal for developing web applications and mobile applications, might as well forget it. Now, C++ has an interface for
So the comment is, for a language to be successful, you have to have a web presence and you have to be on the mobile. Otherwise,
Yes.
what do you do?
Exactly what I
Yes.
said.
Yes. So that's a difficult question to answer, and all I can do now, may I ask your help, maybe volunteering to write the missing pieces for us?
Look, I'm never going to write web applications.
Yes. So web applications is
Maybe to you.
Okay. But the point taken, yes, you have to be on the web and the mobile to be successful today. I'm going to go through, go, easy. Okay, LLVM backend has WebAssembly maybe? Yes, so, yes. So, I mean, I think that answers it. Those are the backends we have. Whatever they provide, we have. Source documentation. This is the most favorite feature of Suresh, who is not here. He loves the fact that the compiler gives you documentation already. This is the old DDoc syntax. So you can say params, returns, throws. And the most beautiful thing is, if you document your unit test block, it becomes a part of the documentation as your example code. So you compile it with -T, and you get it. We have this preview markdown option now. You can use markdown in your documentation. You can color your output with CSS. Everything is great.
So what does this do that Doxy does?
Doxypress.
Wait. Too early.
Doxypress.
Yes,
Don't say that.
can you please? Okay, you're messing up my slides, but it's a good question. So, D wins documentedly. C++ leaves you reaching for Doxypress.
Yes.
So your only option with C++ is Doxypress, and I have a link there. Go get it. Sucks.
Thank you. Say it again.
Doxygen sucks.
That's why it can be used in multiple languages.
Doxygen can be used in multiple languages.
C or C++,
Yes.
Java, that's a huge advantage.
Yes.
Making perfect. So that's
Doxygen, we love Doxygen. We've used it many times.
But it's terrible output.
Yeah, the output is not nice.
Pardon?
I'm happier reading the source code.
That's what you should use Doxypress.
Okay, profiling. So what profiler you use, this is a little crazy, but our compiler, if you compile your code with profile, it includes the profiler. What about code coverage? Compile with -cov, you get code coverage. In the same compiler, same package. Okay, so you've seen this, forward references. We don't need forward references.
So how do you get coverage without test cases?
You have test cases. I mean, I went a little too fast. See this unit test? It's called full 3 with 100. And then I ran.
This is the 10,000 program. How do you do that for the code corpus that has millions of lines of code?
The unit tests are part of the program. It's an interesting stuff.
Okay.
You
All
got
right.
You got about 10 minutes.
Yes. So forward references. We don't use forward references. We don't need them. You just write full and you get full. It works. Magic. We have user-defined attributes. I mentioned this earlier. If you define your own struct as obfuscated, it can be empty, and you can annotate your variables declarations with it. And if you have a serialized function, let's say, which looks at if a member has obfuscated, let me obfuscate, then your Alice, my pet's name struct appears as Alice Caesar in obfuscated. Thread local by default. I wanted to put this here because I use this feature in my code here. So look at this full function. It has an appender, which is the equivalent of all string screen, let's say, of C++. I use the buffer. And I fill this buffer and use the buffer. Then I put static in front of it. I said, why am I creating this garbage memory allocation?